Welcome back to the channel. Today we're going to learn how to solve rate determining step questions. The rate determining step is the slowest step in a multi-step reaction. Let's take an example of an equation of A and 2B reacting to form C and 3D. And let's say the rate equation for this reaction is rate is equal to K, A to the power of 2 multiplied by E. So what does the rate equation actually tell us? The first thing it tells us is that the slow step of the reaction involves 2 moles of A and 1 mole of E. And it also tells us that E is a catalyst because it appears in the rate equation but doesn't appear in the overall equation. Let's see how we can work out a two-step mechanism for the reaction of A and 2B. Let's start by laying out the equation. So write down step 1, step 2, and then write down the overall equation, align the arrows, and then copy the overall equation from the question. Let's call step 1 the slow step and step 2 the fast step. You can see from the rate equation that the slow step must have 2 moles of A and 1 mole of E. So let's put that in and then use that to make one of the products. So let's make C and then combine the remaining elements to make a second product that could be anything sensible. Now F, which doesn't appear in the overall equation. So let's put it in step 2 on the opposite side to cancel it out. And now what's missing from the overall equation that we haven't accounted for is B. So we'll put 2B on the left hand side. On the right, we still have to account for 3D. So let's put that. And we need to cancel one of the A's out because our overall equation only has one A and we have two A's in the first step. So let's put one A in step 2 and then make sure all your elements are balanced and then cancel things that appear on opposite sides. That should leave you with step 1 and step 2 adding up to the overall equation given to you. Okay, let's come to our next problem where we have been given an equation of NO reacting with H2 and we have to propose a two-step mechanism for this reaction that is consistent with the rate equation and identify the rate determining step. So once again we are going to set it out as step 1, step 2 and then we write the overall equation based on what's given to you. So overall is 2NO plus 2H2 gives you N2 and 2H2O. As before, let's choose to call step 1 the slow step and step 2 the fast step. We can see from the rate equation that the slow step involves 2 moles of NO. So let's put that in step 1 and use it to make one of the products, in this case nitrogen. So let's make N2, leaving us with O2. Coming to step 2, in step 2 we have H2 that's missing from our overall equation. So let's put that in. And then we also have O2 which doesn't appear in the overall equation. So let's put it on the opposite side to cancel it out. Now on the right hand side, what's missing is 2H2O. So let's put that in. Next thing to do is make sure that your elements in step 2 are balanced. So you have 4 hydrogens on the left and 4 on the right, and 2 oxygens on the left and 2 on the right. Now let's go ahead and cancel things that are on opposite sides, which are the same, in this case oxygen. So now when you add up step 1 and step 2, you get 2NO plus 2H2 gives you N2 plus 2H2O, which is consistent with your overall equation. Let's look at a different example where ethanol reacts with aqueous cyanide. So again, let's set out step 1, step 2 and the overall equation, and then copy the overall equation from what's given to us in the question. We can see that the slow step requires us to use 1 mole of ethanol and 1 mole of cyanide. So let's do that in step 1 and use that to make a product. In this case, I'm just going to join the 2 compounds together. That's the easiest thing to do. Let's put the product of step 1 as a reactant in step 2. Then looking at the overall equation, what's missing is an H+. Let's put that in. And then again, looking at the overall equation, what's missing is our CH3CHOHCN. So let's put that in as well. Now if you cancel things on opposite sides that are the same, you will be left with an overall equation that matches the one that's given in the question. And your step 1, which is your slow step, will use 1 mole of ethanol and 1 mole of cyanide, which is consistent with what is used in the rate equation. Let's have a look at the reaction of NO with O2, where the rate is KNO2 squared. Let's write down step 1 and step 2, and then write down the overall reaction. Let's call step 1 the slow step or the rate determining step, and step 2 therefore is the fast step. From the rate equation, you can see that the slow step must involve 2 moles of NO. So let's put 2NO as the reactant in step 1 and try and make one of the products. In this case, let's try and make 1NO2. So that leaves us with 1 nitrogen. So let's balance that by putting half N2 on the right. Now N2 does not appear in the overall equation. So to cancel it out, let's put it on the left hand side of step 2. And what's missing is oxygen from the overall equations. Again, that goes on the left hand side in step 2. Now what you need to make is 1 more mole of NO2. So let's make that. And then check that the moles on the second line is all balanced, so the elements are all balanced. So we have 1 nitrogen on either side and 2 oxygens on either side. Now if you cancel the N2 on opposite sides, you will see that your addition of step 1 and step 2 ends up becoming the overall reaction. So you know then that you have got everything balanced properly. This is how you work out a 2-step mechanism that is consistent with the rate equation. Let's take another example of the reaction of NO2 with Cl2, where the rate equation states that NO2 and Cl2 are both first order. Let's write down step 1 and step 2 and then copy the overall equation given to us. You can see that the rate equation states that you need to use 1 mole of NO2 and 1 mole of Cl2 for the slow step, And since we have called step 1 the slow step, we'll put one NO2 and one Cl2 on the left hand side as the reactants in step 1. And we're going to use this to make one of the products. In our case, we'll make a mole of NO2Cl, which leaves us with one Cl, which becomes a Cl radical. To solve step 2, first let's look at the overall equation. So we can see that the overall equation has a second mole of NO2. So let's put that on the left. And then let's put the chloride radical from step 1 on the left in step 2. So they will cancel out and chloride radical won't appear in the overall equation. Then let's use a NO2 and Cl to make another mole of NO2Cl, because we have 2 moles of NO2Cl in the overall equation. If you now add step 1 and step 2, you will see that the chloride radical on the right in step 1 and on the left in step 2 cancels out, and you're left with 2 NO2 and 1 Cl2 on the left and 2 NO2Cl on the right, which is consistent with the overall equation and also has the correct ratios required by the rate equation. We are now going to look at a second kind of problem that comes up in rate determining step questions, which is where we have been given a multi-step reaction and we have to propose a rate equation for this reaction based on what we are told is the slow step. Main thing to remember here is that just because you've been told the third step is the slow step, it doesn't mean that it's just F and D that appear in the rate equation. You have to also take into account all the steps before which are needed to make F and D. To solve this question, you need to take into account everything that comes up to the arrow in the third step, cancelling things that appear on opposite sides are the same. So in our case, if you look at step 1 and step 2, you have C on the right in step 1 and C on the left in step 2, so that cancels out. You also have F on the right in step 1 and F on the left in step 2 before the arrowhead, so F cancels out. You can also cancel out D in the right in step 1 and on the left in step 3. Finally, you have 2B in step 1 and only 1B in step 2. So one of the B's cancels out. So you're left with a rate equation which takes into account everything that hasn't been cancelled. In this case, it is 1 mole of A, so A is first order, 1 mole of B, so B is first order, and 1 mole of E. So this is your rate equation for this reaction where the third step is the slow step. Let's take a different example. This time, step 2 is the slow step. Therefore, we need to include everything up to the arrowhead in step 2 while cancelling things that appear in opposite sides in step 1 and step 2. So in this case, X appears on opposite sides, so it cancels out. And so you're left with 2 moles of NO. So NO is second order and 1 mole of H2. So H2 is first order. Thank you for watching, and I hope this video has helped you to understand rate determining step a bit better. If you have any comments or suggestions for topics, please feel free to leave a note below. If you hit the subscribe button, you'll be notified of when I put out new videos, and you can also contact me on my website, which is onlinebiologyandchemistrytutor.co.uk.